Okay, we wrap this whole section up with applications of parametric equations. So how to use parametric equations to solve a projection motion problem. So the idea here is instead of having like y equals something in terms of x, we can come up with an equation for x so we know the horizontal change, and the equation for y so we know the vertical change. And we use the other parameter like time. So the horizontal distance is given by x equals v naught, that's the v naught, the initial velocity, times cosine of theta times t. And we substitute the initial speed of the object for v naught. The expression cosine theta indicates the angle at which the object is propelled. Substitute that angle in degrees for cosine theta. The vertical distance is given by the formula y equals -1/2 gt squared plus v naught sine theta t plus h. So -1/2 gt squared represents the effect of gravity, and so depends on the situation. If we're doing the English or imperial system, it's feet per second squared, so 32 feet per second squared. If we're doing the metric system, it's 9.8 meters per second squared. Again, substitute the initial speed for v naught and the initial height at which the object was propelled for h, and proceed by calculating each term to solve for t. Okay, so here's our fun-filled problem. I've seen this done before, like with a basketball. If you're throwing a basketball, this one's a baseball problem. Solve the problem presented at the beginning of this section. Oh, I didn't present that problem to you. Does the batter hit the game-winning home run? Assume that the ball is hit with an initial velocity of 140 feet per second. So our v sub 0, turn my pencil on, v sub 0 is 140. And the initial angle theta is, or the angle, is 45 degrees. And making the contact 3 feet above the ground, so h equals 3. So find the parametric equation to model the path of the baseball. So our x of t is going to be, recall it's v naught times cosine of theta times t. So it's going to be 140 times cosine of 45 degrees times t, or 140 times cosine of 45 degrees is square root of 2 over 2 times t. So it's 70 times the square root of 2 times t. And our y of t is going to be, it was -1/2 gt squared plus v naught times sine of theta times t plus h. So let's fill in the pieces we know. This is in terms of feet, so we'll use the 32 feet per second. Y of t is -1/2 times 32 times t squared plus, and our initial velocity was 140, times sine of 45 degrees times t plus 3. So y of t would be -16 t squared plus, that's 140 times the square root of 2 over 2, sine of 45 is square root of 2 over 2 times t plus 3, or y of t is -16 t squared plus 70 times the square root of 2 times t plus 3. Okay, so those are our two equations. Where's the ball after 2 seconds? So x of 2 is going to be 70 times the square root of 2 times 2. So that's going to be approximately 198 feet. Y of 2 is going to be -16 times 2 squared plus 140 times sine, well, I already have that worked out. So it was 70 times the square root of 2 times 2 plus 3, and I get approximately 137 feet. Okay, so that was part 2. So this is part 1. This is part 2. Part 3, how long is the ball in the air? So we want to know at what time will it be back down, have a height of 0. So for 3, we're going to look at when is y of t equal to 0. So we're looking at negative 16t squared plus 70 times the square root of 2t plus 3 equals 0. And we can use a quadratic formula. T is equal to negative 70 times the square root of 2 plus or minus the square root of 70 times the square root of 2 squared minus 4 times negative 16 times 3 all over 2 times negative 16. Excuse me, you're going to get 2 answers from this. But the one we're going to go with is, so you'll get a positive and a negative. You can't go back in time. So our t we're going to go with is 6.2173 seconds. And so our last question is it a home run? So it'd be a home run. There's information from the earlier part of the problem. So what we have to do is it has to go over the wall at 400 feet. So how high is it at 400 feet? I think the wall, it might be like 12, 15 feet high, 10 feet high. So for part 4, we need to know at what time it's going to be at 400 feet. So when is the ball at 400 feet? And then we'll be able to find out how high it is at that time. So we can take our, so when is x of t equal to 400? So that's asking when is 70 times the square root of 2 times t equal to 400. So we could divide by 70 times the square root of 2. So t would be equal to 4.04 seconds. So now we look at the height. So what is the height at 4.04 seconds? Y of t is negative 16 times 4.04 squared plus 70 times the square root of 2 times 4.04 plus 3. And that we get about 141.8 feet. So it is high enough. That's it.